can be conduct electricity. Reductive doping, on the other hand, involves addition of an electron or a reducing agent to the polymer. So oxidative doping means addition of an electron or acceptor or the oxidizing agent to the polymer. Reductive doping means addition of a electron or a reducing agent to the polymer. Even the physical and chemical property can be manipulated to improve the processability. For example, poly 3,4 ethylene dioxythiophene, which is insoluble in water, could be uniformly disposed after doping with negatively charged water soluble polystyrene sulfonate. So, a polymer which was initially insoluble in water can be solubilized just by adding dopant. So dopant has a greater role to play. In the doped state, the backbone of a conducting polymer consists of a delocalized pi system, while in the undoped state, the polymer may have a conjugated backbone or a non-conjugated backbone or a non-conjugated structure as an so either in the doped state, definitely you have a conjugation. Along with conjugation, you have either extra electron or you have a hole. But in non-undoped system, in undoped polymer, which also can conduct electricity, or to a lesser extent, it has either a conjugated backbone or a non-conjugated backbone. Then synthesis of conducting polymers, chemical polymerization. Suppose you take pyrrole. Pyrrole is a 5-member ring containing nitrogen containing compound. It is also aromatic compound. Then from pyrrole you will get polypyrrole by the doing the polymerization reaction. Then also electrochemical polymerization, you can get the conducting polymer. So there are different way to get the conducting polymer. Then the emulsion polymerization. In this process, hydrophobic monomers are emulsified into an aqueous solution using a surfactant. So emulsion means you have to add a surfactant in order to get the emulsion. So the hydrophobic monomers are emulsified into a aqueous solution using a surfactant. So they are that means the hydrophobic monomers, they are dispersed in the aqueous phase by using a surfactant. Surfactant are surface active agents. The monomers thus form droplets that polymerize to give a polymer having a control size. The size of the polymer normally ranges from 50 to 500 nanometer. The narrow size distribution of the polymer is important for many applications. The latex so derived can be used in paints, adhesives, coatings, drug delivery, cosmetics, and other applications. Then comes mechanism of conduction, how the conduction takes place. So, in order to understand the mechanism of conduction, you have to understand the band theory. Band theory says any solid if you take, it can be either a conductor or a semiconductor or an insulator. So, for a conductor, the valence band and the conduction band, they should overlap each other. There should be zero energy gap. For a semiconductor, the energy gap between the valence band and the conduction band is very small, around 0.1 to 3 electron volt. And when the valence band and conduction band energy gap is too high, greater than 3 electron volt, that is called insulator. So any solid can be categorized, so also the polymer can be categorized as conductor, semiconductor, or insulator. The energy gap between two type of bands are called band gap, the fundamental energy gap. In metals, by supplying a small amount of energy, electron from the lower level can be excited to the higher level. If the band gap is large, as in the insulator, the electron cannot be promoted from the filled valence band to the vacant conduction band. In semiconductor, the gap is smaller and hence they exhibit some conductivity. Since conducting polymers have conjugated structure, the extent of the delocalization determines the energy gap. As electrons are charge carriers, in So as electrons are charge carriers in metals, the intrinsic charge carrier are not present in conducting polymers. Their conductivity and band gaps are illustrated here. So suppose there are some examples. One second. For example, polyacetylene, the band gap is 1.5 electron volt. Its conductivity is expressed in Simon per centimeter. Then polythiophene, polyparaphenylene, vinylene, polypyrrole, polyaniline, its band gap as well as conductivity has been given. Then charge carriers. The conducting polymers are to be partially oxidized with electron acceptor or partially reduced with electron donor, which are known as p doping or n doping. So p doping means partially oxidized, n doping means partially reduced. So with donors, you can either do the oxidation or you can do the reduction. Such process lead to the formation of paralones, biparalones, and solitons, which we now study. So there are different kind of addition of the dopants. So depending on the addition of the dopants, you will get different kind of structure. So here is the structure of paralone formation in unodexahexene. So undecahexene, hexene, you will get this kind of structure, and this is called paralone. So one parallel, two parallels, three biparallel. The exact examples are here. So two positive charges on the parallel moves as a pair and are not independent. So if there are two positive charges close by, then that is called bipolaron. So one positive charge, then there is a conjugation, then another positive charge, then there is two polarons. And only one positive charge is there, then that is called one polaron. Okay, so application of conductive polymers. This conductive polymer can be applied in biosensors, in tissue engineering, in drug delivery, in artificial muscles. So you can use these conducting polymers. Now the last unit, the stimuli response of polymers. So after reading this unit, you would be able to explain the meaning of stimuli. What are the stimuli? One second. So what are these stimuli responsive polymers? We'll see. One second. These are polymers which respond to a small change in physical or chemical or biological condition and exhibit large phase or properly changes. These changes are reversible and the system returns to its original state when the stimulus is removed. These polymers are also called smart, intelligent, or environmentally sensitive polymers. So the stimuli responsive polymers are also known as smart polymer or intelligent polymer or environmental sensitive polymers. In these polymers, they respond to small change in physical or chemical or biological condition. So stimuli can be physical changes, can be chemical stimuli, it can be biological stimuli. So physical stimuli in term of mechanical stimuli, light, temperature, magnetic and electric. Chemical stimuli in term of pH, ionic strength, solvent, electrochemical or redox reactions. Then biological stimuli, it is enzymes, proteins, antibiotics, and saccharides. They are responsible for this biological stimuli. Then pH responsive smart polymers. pH respond to the change in the pH and can undergo structural and property changes such as surface activity, solubility, hydrophilicity, chain hydrophobicity, volume conformation, and configuration. The pH responsive polymer can be classified on the basis of their origin, ionizable groups, and structure. This is shown as a flowchart here. By origin, pH responsive polymers can be natural polymers or synthetic polymers. Then pH by ionizing groups, they can be polyacids or polybases. So pH responsive polymer means it can be acid group they are present or base. So it will be polyacid or polybase. Then by structure, the pH responsive polymers can be hydrogel, it can be branched, it can be dendrimers, it can be micelles, it can be linear chain, it can be block. So these are different kind of pH responsive polymers. So polymer example, then nature, then swelling pH. So polycarboxylic acid, these are anionic polymers, then their swelling is in basic pH. So some polymer they get swelled in basic pH, some polymer they get swelled in acidic pH. So according to the ionizable groups, they are either polyacid, as I mentioned, or polybases. In polyacid, there will be acidic groups, terminal groups. In polybases, there are basic like NH2 groups, amine groups will be present in that. So tertiary amino groups, secondary amino groups, or imidazole groups. These are all polybases. Then according to the structure, they are the pH responsive polymers. They are differentiated into linear block polymers, star polymers, hydrogels. So hydrogels are hydrophilic polymers which are cross-linked into an insoluble but highly hydrophilic structure. They absorb hundred of times water as compared to the dry weight. So hydrogels they generally they absorb large amount of water. So they absorb up to 100 times of their own weight of water. They are called chemically gels or permanent gels when they are covalently cross-linked. So synthetic strategies. So these stimuli responsive polymers can be synthesized using different kind of strategies like emulsion polymerization, group transfer radical polymerization, atom transfer radical polymerization, and control radical polymerization. So these are the methods for synthesis of these stimuli responsive polymers. Then application of pH sensitive smart polymers. They are applicable. They are applied in the delivery of therapeutic agent. Suppose you have to deliver some therapeutic agent inside your body. So maybe that polymer will swell in basic pH or acidic pH. Like in the saliva or in your mouth, it can swell to release that drug, or it can swell in the stomach to release that drug. So the drug molecule will be released. So they are used as a delivery of therapeutic agents. In different pH, they will swell and release the drug. And they are also used as biomaterials. pH responsive hydrogels can change their swelling behavior according to the pH of the wound and hence facilitates tissue generation. The pH responsive biomaterials are used in implant, coating, and other application when such behavior is desired. Biomaterials are natural or synthetic substances which are designed to interact with the biological system for therapeutic and diagnostic purposes. Such materials should be biocompatible. They should not cause any harmful or adverse effect, responsible and biodegradable. So these polymers are mostly biodegradable polymers as I was talking about. These are used in biomaterials. These materials are used to support, enhance, or replace any damaged tissue or a biological function. They could be used in the form of coating, fiber, or film. In addition to their applications such as heart valve, stent, ligament, dental implant, contact lenses, they can be used as biosensors and in drug delivery as well as in the wound healing. Such materials could be metal, ceramic, living cells. So biomaterials can be also metals. It can be ceramic. It can be polymer. You have studied about some such in functions above here. The pH responsive polymers were used as a drug delivery. They are numerous in examples. Methacrylate and methyl methacrylate based polymers are used as entering coating polymers. Such coating are useful for anti-inflammatory drugs such as diclofenac, potassium sodium naproxen, and omeprazole. They are also used in delivery of insulin in case of diabetic patient. They are used in the delivery of arithmetic drugs such as salbutamol is also well known. Some other pH responsive polymers used in drug delivery are methyl cellulose, sodium alginate. Alginate is a natural polymer. Cellulose is also natural polymer. Cellulose acetate, then chitosan. It is also natural polymer. These they are all pH responsive polymers or pH sensitive polymers. Okay, so this brings to the end of this first unit, then 4 units of this syllabus. Then the next one I will discuss tomorrow. Anybody there?
Okay, sir.
So you go through this part. Then if you have any difficulty, tomorrow we will again discuss.
Sir, may we
Hello.
have any sir? Pardon, sir. Can you hear us?
Yes.
Sir, may we have any contact number or something in case we need to ask something like email ID or contact number?
Yes, you can note down my email ID and contact number.
Yes, sir.
My contact number is 88951
8895193144.
93144.
double eight
Yeah.
nine five one nine three one double four.
Yes. My email ID is PPARHI
Double PARHI.
@ravenshauniversity.ac.in. So you go through this block one, then tomorrow we will discuss if you have some doubt on this, or otherwise we will go to the block two. We have to
Okay, sir.
finish 4 blocks in 4 days. So today the first day that it is block one has been completed, or more or less we have given you a idea about what is about all this written in the block one. But you have to read it because this is 110 pages, and you have to read all those pages to see if you can understand all the things. Otherwise, we can discuss it.
Okay, sir. Thank you. Sir, I'm audible.
Yes, you are audible.
Sir, please share this material with us. It will be help us for revision and study because the
Okay, sure.
material are not available in e-Gyan Kosak.
Okay, so you all, I already told you my email ID. So otherwise, you make a WhatsApp group. There I will share everything.
Sir,
Okay,
official WhatsApp group is there, sir.
Okay, then you add me there in the WhatsApp group. So I will send it.
okay,
Sir,
sir.
I'm not permitted. Admins can add, sir. IGNU admins can add
Okay,
you,
so I
sir.
will ask them to add me so that I can share.
Yes, sir.
That's it,
Okay,
sir.
sir.
Thank
Thank
you,
you,
sir.
sir.
Okay, then see you tomorrow at 6 o'clock.
Okay, sir. Thank you so much, sir.
Okay, sir. Thank you.
Thank you, sir.
Thank you, sir.